So now I'm going to get into some general cryptographic concepts that underlie cryptocurrencies. So how many people have heard about or know what public key cryptography is? Okay, so public key cryptography is basically just a way to send things cryptographically, obviously, right? So if we have a key, and I'm going to make, I believe you guys in a previous lecture went over cryptography, like classic cryptography, right? Yes? Okay. So basically all those classic cryptography protocols are cryptographic schemes were symmetric key. So you had one key that was shared between two parties, and you basically just did everything through that one key, right? Now, if I'm going to make an analogy with current locks today, and you go and open a lock for your apartment or whatever, for a door, you have one key that opens and closes that door. So symmetric key cryptography is pretty easy to think of in that way. Key cryptography, you have a public key, which you share with the entire world, and you have your own private key, which you keep to yourself. So the way that you can think of this in a lock scenario is basically, if we can imagine a lock that works with two keys, and one way you can turn the lock, or you can turn the lock one way with one key, but you can't turn it back the other way. And then with your private key, you can turn it the other way, but you can't turn it back, right? So what this means is that you can go from an unencrypted state to an encrypted state, but without the corresponding private key, you can't unencrypt that data back again. So this allows, basically, if I'm just holding my private key and I let anybody send me encrypted messages, nobody except me, I'm sorry, hold on. Nobody except me is going to be able to read what those encrypted messages are. So what's really interesting about this is that obviously I don't have to trust somebody else that with my key, right? So with symmetric key, you have to trust both parties. If I'm going to share a key with Elon, for example, and I'm really secure with my key, but maybe Elon's not so secure with his, and somebody finds out the key through him, I'm screwed as well. So that's not good, and that's why public key cryptography is really good as like from a trust concept or from a trust perspective, because I don't have to trust Elon anymore. Elon has my public key, he can send me stuff, and I just have to make sure that I'm securing my own private key. So it's really good for encrypting messages and not trusting. But another thing that we can do with public key cryptography is we can do these things called digital signatures. So what digital signatures are basically just it's basically a way of saying that a message has come from me and it could have only come from me. And the way this happens, the way that this works is that when I encrypt a message and I basically have my private key, I can say that this encrypted, I encrypt something with my private key and somebody can unencrypt it with the public key. So since I'm the only one that has my private key, everybody knows that I was the only one that could have actually encrypted that message, and therefore the message must have come from me. Okay, the other big general cryptographic concept that we're going to go into is hashing. So what hashing is, and I think Elon covered this as well in a previous, briefly, but basically what hashing is another concept, another way to put it is that it's a one-way function. So what this means is if I put one input in the hashing function, then that output cannot be reversed. So if we take a normal function here, right, a general algebraic expression, we can see that if we plug in, if we give an input we can easily reverse it and get the output back. But with hashing functions, whatever I input, there's no possible way at all to basically go backwards and see what I input from the output of the hash. And basically what you do when you're hashing is, or what the hashing function does, is any input that I put in spits out basically a string of characters that looks totally random. But if I put that same thing in over and over again, I'm going to get that same hash over and over again. So as you can see here, there's some examples of different hashes. And you can see that there's absolutely no correlation. It's completely random. There's no mathematical way to even find a collision that we know of right now. It's out there, but nobody has ever done it, and nobody will probably ever do it until quantum computers come out. So I'm going to get into some specific cryptocurrency concepts now. So the big thing to keep in mind when thinking about cryptocurrency are these three separate roles that go into it. So there are the users, which are the people that are using the cryptocurrency. They have their wallet, they're moving it around, they're holding it. They're what give value to the cryptocurrency because of supply and demand. Basically, that's all the value of cryptocurrency is. It's just supply and demand. Next, we have the miners. And I'm going to go deep into mining later on. But just as an overview right now, miners are basically these computers that people set up that are securing the network. So what miners do is that they are putting all the work into the network to secure it, and it's what brings the entire network to consensus about the state of everybody's balances. And then we have the nodes. So the nodes are basically the entities that people just voluntarily set up. There's no real incentive for them to do it, but they verify the state of all the balances on the network. So the nodes are the verification. The miners are what secure the network, and the users give value to the cryptocurrency or develop applications on top of it, or what have you. And another thing that I forgot to mention, miners, the only way that new cryptocurrency comes into the network is through miners, and I'll get into that later when we talk about mining. So the first concept that we want to go over is the concept of a wallet. Now, a wallet is just software that you download that is just managing your private and public keys for you. And basically, it's just a way that it makes it easy for people to just send and use cryptocurrency. So they hold different addresses for you. And I'm going to talk about addresses right now. But basically, it's just the software that everybody uses to interact with to send and interact with the blockchain and that cryptocurrency. So addresses. Now, addresses can be thought of as the public key for your wallet. So when I want somebody to send me payments to my wallet and I want to receive payments in cryptocurrency, I send them my address, and then they use their wallet to send coins to me. Now, addresses have a public key and a private key. And this private key is kept in my own wallet. I don't share it with anybody. If anybody has access to that private key, they would be able to get my coins, basically. So now from a security perspective, addresses should only be used once. And now the reason for this is when you go, and you'll see when we start setting up our own wallets, but when you set up your wallet, you are given a private key, and this is like a master private key. And that holds everything about your wallet. Then you have this private key basically generates all the addresses which are associated with their own private key and their own public key. So basically, if you do use these addresses more than once, it's possible that people can find out information about you. Otherwise, it's totally pseudo-anonymous network. I mean, nobody has to put in any verification of their credentials or anything to partake in this. So if you only use addresses once, nobody will really know your identity. So that's an important security perspective. Okay, moving on. Now, transactions are probably the most complicated thing about cryptocurrency. So when we talk about Bitcoin or Litecoin, basically we have to think of the concept about what is a coin, right? So these coins are basically just represented as transaction outputs. So whenever I send my coins to somebody else, right, through the wallet, to somebody else's address, that generates a transaction, which will be relayed to the network. And when and these transactions are basically representations of coins. So a transaction is going to contain the inputs that you put in. So if I hold a coin, it means that I hold the transaction for that coin. Or it means that I hold a transaction, and then I can use that transaction to send money to other people. So the inputs would be the coins that I have right now. And basically, whenever I go to send a transaction, I need to be the one signing the message that I approve of the transaction with the private key that I own. Because if somebody else is going to try and basically spend my coins, the nodes that verify the network can easily just detect immediately that the signatures don't match up. That basically the person that holds the coins is not the one that's trying to spend them. So that's why we have this signature in the transaction, and that goes back to digital signatures that we talked about earlier. So when I go and send, let's say I have one Bitcoin or one Litecoin, and I want to send 0.2 to somebody. So it means that I send, when I send 0.2 and then they get their 0.2 and I get my 0.8, this is basically a splitting of transactions. So basically, when I'm creating that transaction, I'm signing it to make sure that it's verified on my end, right? I'm also sending it to somebody's private, to somebody's address. So their public key is attached to that. So the network knows that who is receiving those coins and who is sending those coins, and they can verify that. Now, we also have these inputs and outputs. So if we look at this transaction log, transaction 1 and transaction 2, it might be a little bit more clear. But when I have one Litecoin and I want to send that to somebody, and I want to send 0.2 to somebody, basically I'm getting my transaction that I own, which is in my wallet. My wallet's taking care of all that. I put that, I send a transaction of 1 to the network, and it gets split into 0.8, which is my change. And the way we can think about this, if we think about physical money, is if I have $10 and I'm spending 6 of it at a physical location, I'm receiving $4 change, and they're getting $6, right? So basically, the reason that it's like this is that it can be completely traced. Everything can be totally traced back on the network. Every single transaction can be traced back to the beginning of the entire network. And this is how we validate that everybody has the right balances and stuff like that. So when somebody receives their transaction, so I sent 0.2 to Joel, and I got 0.8 back. Now I have a transaction output in my wallet worth 0.8. Joel has a transaction output in his wallet worth 0.2. And then whenever these people want to send transactions themselves, it's going to get split again from my personal transaction inputs. So I got my 0.8 change, and I want to send it to somebody else. I'm going to use in my inputs my 0.8, and I'm going to get the change back from whatever I sent. Okay, so here's where it starts coming together. I know it seems like it's a little bit all over the place now, but hopefully this will bring it together. So what blocks are they're literally just groups of transactions. So when somebody sends Bitcoin or cryptocurrency to somebody else, that transaction gets relayed to the nodes. And these nodes verify that everything's correct with my own signature and with basically saying that I'm the one able to spend it. Now these nodes basically hold all of the transactions that have not yet been included in a block. So what the miners do when they go and validate these transactions is they go to the nodes and they ask them for any unverified transactions that they can include in the block. So they group up all these transactions and put them in a block, and then they go and start verifying those transactions. And that's a part of the mining that we're going to get into. So once the block is verified by the miners, it gets added to the network, to the blockchain of the network, and basically all these blocks are linked together. So when I add a block to the network, that block has the list of unconfirmed transactions that have been introduced to the network, have been spent from everybody all over. And they also include the hash of the previous block. So when this gets validated, we know that the previous block, if we assume that the previous block was valid, we know that the next block that was added on top of that is linked to the previous block. So what this means is if somebody tries to go back and they try and claim or publish a new block and try and claim that a different transaction has happened, we're able to see that basically we're able to detect that that transaction was fraudulent and that didn't actually happen on the network. And that's going to come together with mining. So finally, the last point that I want to make is what mining is. So when miners go to the nodes and they ask for unconfirmed transactions to fit into a block, what they're doing is they basically are running and trying to solve a hashing puzzle. Now, what this hashing puzzle is basically is that if you look down at the bottom here and you see these certain number of zeros at the front, basically, if you remember back to hashing, whenever I put something into the hashing function, something totally random is spit out, right? So the chance that you have these certain amount of zeros at the front of any sort of hash is astronomically small. So what this means is that people are running hashes all the time. Miners are running hashes just over and over again on on the block that they're trying to validate. That all the transactions are put in, they're trying to validate a block, and they're just running hashes on that block. So when basically it's like 1 over 2 to a very large number chance that you're going to find a certain amount of zeros at the front for this certain hash that we're trying to validate. Now, why does this matter at all, right? So when miners are trying to find this hash, they're expending electricity. And what this means is that they have a stake in basically putting out the correct and valid blocks out to the blockchain to be included, or valid blocks to be included into the blockchain. So basically, what happens is people are able to basically. I'm sorry, hold on. What this means is that everybody comes to basically a consensus about what the next block is, because when people have a stake in something being valid and they're running and expending all this electricity, these people, basically everybody else that is trying to also validate blocks is going to be basically everybody else that's trying to validate these blocks knows that what that person has sent is valid, because if it was not valid, then the nodes could either, one, reject it automatically if it didn't have the right number of zeros at the front, because it's very easy to confirm that a hash of a block, if you put this hash of the block or put all of the transactions and the previous block hash into the hashing function, it should spit out the same thing, right? So if a miner says that they hashed and found the right hash for a block, basically, if the miners didn't basically go through that legitimately, a node could check immediately that it was not correct, because they could easily just run the hashing function and see that it wasn't right. But suppose that it did work out, right? Now we have somebody that has published a block to the network, and let's say somebody else comes along and tries to publish another block on that same network. Now we have sort of like a conflict of interest, right? We have one way that it could go, basically one sort of valid, potentially valid solution for these transactions, and another potentially valid transaction, basically valid blockchain that or valid listing of all the account balances. So basically what miners do is, once they see that a new block has been added, they start working on either that new block if they trust that that block is legitimate, or they can just start working on something else. Or they can choose between what is the right block, basically. And so when the miners are choosing what block is correct, if the majority of the people are working on one basically option of this validation, then eventually this basically option is going to have more work behind it, and it's going to get more blocks added into the blockchain. Yeah, Elon.
I'm going to miss this part, but my question is that, you were talking about incentives for mining and incentives for node installation. And you're going to get about what mining is and how it works, but what exactly, I'm still not seeing, what exactly is the incentive for miners to mine? Because they're spending a lot of electricity and cost.
Right. So basically, whenever miners validate a block, and they are allowed to basically add a transaction out of thin air that basically increases the monetary supply, and they're able to send themselves a certain amount of cryptocurrency. So for Bitcoin, there's only ever gonna be a limited supply, right? So right now, if you publish a valid block, then you get 12.5 Bitcoin as a reward.
Wow, so that's like
Yeah, it's like $60,000, right? But it takes a whole lot of electricity to sort of verify and go through the mining process.
75K.
75K.
Yeah.
So there are companies that will allow you to kind of pay and use their mining resources and reap the benefits, right? How do they, like, why do they do that? Why don't they just mine themselves? Because the benefits are tangible from the transactions that they create. You know, do you understand what I'm saying?
Are you talking about pools?
Yeah,
Basically?
mining.
It's like buying lottery tickets at 1,000. Increase your chances of getting that jackpot.
Exactly. So since it's totally random, that anybody has a random chance of finding this this certain hash that we say that it needs to conform to, right? By some dumb luck, a 1/2 to the 50 or something chance, I'm able to get it on the first try. Then, hey, I validated it. I sent a valid thing on my first try. But the way that the algorithm works is that blocks are only supposed to be validated roughly every 10 minutes. So obviously, it's totally random that I'm trying to find this hash. If we take the average of basically all the computing power trying to find this hash, and the difficulty of actually trying to get it, or the probability that you find this specific a specific hash that fits that form, that all works out to about 10 minutes. So new blocks come in every 10 minutes about.
That basically, I was going to ask, like, how long does it take to verify a new block?
Yeah, the algorithm is basically set up so that it's in Bitcoin, it's going to be 10 minutes. In other cryptocurrencies, it can be totally different. Litecoin is 2.5 minutes. I mean, there are literally thousands of cryptocurrencies out there that all employ different algorithms and basically different consensus protocols. Yeah.
I'm still like a little confused as to why it's so necessary to have those string of zeros.
Okay, so when I put something into a hashing function, it's totally random what comes out, right? So if I'm going to put the number, or if we go back to addresses, sorry, if we go back to hashing in general,
Yeah.
and we see that the hash of hello spits out this certain this string of characters, right? This is totally random. It's if I put that same thing in there, it's gonna spit out the exact same hash. But basically, because I'm hashing all the transactions in a block, as well as the previous block hash, along with basically this you can think of it as digital, like just random garbage called a nonce. And basically, it's not exactly digital garbage, but it adds randomness to the outputs of hashes. So nobody knows how to get a certain hash that would be a certain amount of zeros at the front. So because it's totally random, and it's a really small chance, we take all the people that are contributing towards the network in the form of mining, put it over this probability that you find the hash, and then that comes out to roughly 10 minutes. So yeah, because there's this added element of randomness with the nonce, I can't just say, okay, I have a hello, like let's say the word yes came out to a certain amount of zeros at the front. I couldn't just keep sending that in as a valid hash, because with this nonce, it's going to be random after every single block that comes in. Does that make sense? Did I answer your question?
Is that kind of like solving?
Yes, it's similar to salting in that there's I wouldn't compare it too much to salting. I'm not too confident about my understanding about salting, but if there's an element of randomness in salting, then yes, it's comparable. Okay, so
I think salting is to prevent two unique hashes, right?
Yes.
So basically, like if you hash a password, it will create an irreversible hash, right? Like let's say he was talking about hello world or world or hello. Well, yes, it's a one-way function, but if you hash, if someone else has a password that's hello as well, then the hash is going to be the same. So if you have two, let's say you have several user accounts in the same system and they are using the same password, then if you can look at the hashes and the users, then you can see two users, maybe different users that have the same hashes, and then inadvertently know that another user is using the same hash, and ergo the same password. And that's how one user, I mean, I might be wrong about this, but I feel like I'm close, is that might be how one user can accidentally know what another user's password is, and that's to prevent that they use a salt, which is prefixed or added to a hash to keep it still unique. Does that make sense? Yeah.
So because you're hashing the same thing, the same password sort of with that added salt, it adds an element of randomness. So you can sort of make that comparison, yeah.
Well, it seems like so this is this random token to generate some string with a bunch of zeros in front. Right? So it's like if you were just to replay that, you could just keep getting blocks over and over again.
Right. So the thing that prevents that is the block of the hash of the previous block gets added into the new block that you're trying to verify.
Okay.
So if I were to try and publish the same block, it wouldn't match up to the previous block as well.
So what I'm hearing is like a lot of this guessing is just like completely random. Like, is there any sort of algorithmic way to like do these hashes, or just like whatever we try?
It's completely random. It's dumb luck, random chance that anybody in particular finds a specific hash.
But you can increase your probability if you have a stronger computer, because you can generate
so you can do more
hashes.
operations at a time.
Yeah.
Exactly. So it's all dependent on how many.
Brute force is the only way.
Exactly. Brute force is the only
no
way.
intelligent like attacking method other than brute. Basically, it's the most simplest. Try every possible option.
That's the only option.
If that wasn't the case, then the hash function would be broken.
Well, no, because you can dictionary that. In other instances, like on passwords, a lot of people, humans write human readable, or or humans make passwords the way humans make passwords. They don't make completely random passwords. So you can intelligently attack human passwords, but you can't intelligently attack these transaction blocks. Right? That's what you're saying.
Exactly. Because
transaction blocks are like they're not like hashes people create that are turned into hashes. They're just like completely random.
But you can't minimize them by maybe the most common average transaction, or maybe the limit of transactions. Most people aren't sending 100 Bitcoin, so maybe you can limit the hashing by how you can still get the hashing algorithm, right? So if you can see how the hashing algorithm implements the number of transactions and implements that into the part of the hash, then couldn't you kind of narrow your hashing, your attack by saying people aren't normally sending 100 Bitcoin, so I'm going to attack the next transaction, and exclude those possible options, kind of thing. That works. With more intelligent guessing scheme. There's no.
it's completely brute force is the only option. You can only just try a whole bunch of different nonces, so that basically all you can do is keep increasing the nonce count and keep trying different nonces to try and get this hash. So if we didn't have the hash of the previous block, then basically I could just run the same hash on all of the transactions in that block, and it would come out to the same exact thing. But because we have the hash of the previous block as well as this element of randomness with the nonce, then we're able to basically connect it to a specific, basically we're able to timestamp when that happened, because blocks come in every 10 minutes. if we need the previous block included in our new block, we know that that came in after 10 minutes. So we have a timestamp for it, and basically we know that it is legitimate because the element of randomness in the nonce means that we can't just run the same hash on all the transactions. So basically, when these miners are, what mining does is it basically means that everybody comes to a consensus about the network. So there are cryptocurrencies out there that basically don't have mining at all. They have different, basically consensus algorithms that you can, it's just a way of the entire network coming into agreement about what transactions happened. So that's all I have for mining, and that's all I have for the presentation. So I know I didn't do the best of jobs, but is there anything that I need to clarify?
So why are there multiple cryptocurrencies? And why is it growing? Like there are more than 40 now.
Yeah. So there are over 1,000, and there's a Gator coin that somebody created. Yes, it's out there. So basically, all these different parameters that we have here, the fact that blocks come in every 10 minutes. Who's to say that it needs to come in every 10 minutes, right? The fact that there's only 21 million Bitcoin that there's ever going to be, who set that limit? Basically, all these different cryptocurrencies can change these parameters, and when you change the parameters, you have to have a new coin. You have to create a new currency that people will follow.
Because they're based on supply and demand, is there any way they can be like demonetized if something happens with the hash or anything with the way that they create the hashes? Like if someone managed to crack it, they would basically make nothing.
So with current technology, no, it's impossible to crack. If quantum computers come and crack it, basically there's a way that everybody can agree that basically not to follow this new, basically if somebody were to crack it, right, they would create transactions saying that they would be able to validate transactions, validate blocks immediately, right? So they'd be able to get all the rewards. But what would happen is people would basically say, no, none of those blocks are valid. I'm not going to accept that. And then people would change, they would go in and change what the algorithm is that secures any sort of cryptocurrency that they have.
So why is Bitcoin the most popular? Is it because a lot of people are using it because it's popular, or is it because it's popular because a lot of people are using it?
Yeah, so that's very interesting. It's just like the network effect. I mean, in terms of a technical, from a technical perspective, there are cryptocurrencies that excel way better than Bitcoin in certain aspects. And so because Bitcoin was the first, that's pretty much the only reason why.
Because people have been using it the longest. Basically.
People have been using it. It's all totally network effect. There's nothing to say that it couldn't, some other cryptocurrency couldn't take the lead or anything like that.
Could you explain the concept of, like, so I know like Bitcoin has like a difficulty metric that it's always like changing to make sure everything stays at 10 minutes. So is the difficulty metric the number of zeros you define essentially?
That's exactly what it is.
Okay.
So
it's the probability such that it solves like an equation to make it 10 minutes.
Right.
Given the current rate of solving.
Exactly. So when you're running these hash function, these hashing algorithms, and a certain hashing algorithm that Bitcoin uses is called SHA-256, and this outputs 256 random ones or zeros. I don't know exactly what it is right now for Bitcoin, but basically I think it's there's a certain amount of zeros. Let's just say 40 for right now. Basically, the chance that you find a certain hash that has 40 starting zeros is 2 to the 40, because it could be, it's sort of like, you can think of it as binary if you guys are familiar with binary addition and so math.
I also heard that the more that's out there, the longer it's out there, the harder it gets, the slower they are to generate. Is that your understanding?
What is slower to generate?
The hashing takes longer and longer the more time. With the complexity, the more zeros that you're trying to get, the longer it's going to take.
Exactly, because if I have, let's say I just need to find just 1 0 at the front. And well, because this is a hex string, 1 0 would actually be 4 zeros in your bit sequence. But that would be 2 to the 4 chance that I find that particular a hash that has that many zeros at the front. So 2 to the 4 is 16. I mean, I could, like, your computer can do that in nanoseconds.
So you're saying that the more Bitcoin are purchased, or the more Bitcoin volume, not Bitcoin volume, but I guess the more blocks that are cracked, the less zeros there will be. Like, is it kind of like will they introduce the next 0, or is the 0, how can I put this better?
I think I understand exactly what you're
The
saying.
zeros grow. Okay.
That's the thing. That's
Okay, I thought the 0 was a way of minimizing the amount of guessing for the hash, like reducing the possibilities.
Yeah, so
but you're saying that the zeros are actually going to grow.
it's a dynamic scale. So whenever I'm contributing to the network, I contribute a certain amount of hashes per second to the network, right? But the network is supposed to have blocks come in every roughly 10 minutes. So what happens is the amount of zeros that I have to find at the front for any particular hash can either increase or decrease depending on how many people are contributing their power to the network. So that blocks come in every 10 minutes.
So the more miners you have, the more zeros are needed to find the hash, but also with the more people you have, the less zero, like the more people you have using the less zeros.
No, the users have nothing to do with it. It's all about miners and the amount of hashes that are being put into the network. So
more people using it, don't you have more hashes?
no, so the only people that are running these hashes are the miners.
Okay.
Users don't have to do any of this. They just send and receive, and that's all they have to know from their perspective. What that does is when they send and receive, it's a new transaction. That new transaction eventually gets placed into a block. The miners start running their hashing algorithms to validate all the transactions that are in a block. And then once it gets included and it's verified to be a legitimate block, then the transfer of your cryptocurrency is actually done.
So does that mean? Sorry, you
Just a simple one. I've looked at Bitcoin a lot, but one of the things that they say a lot about it is that it's very volatile in its value. What about it? What about cryptocurrencies make its value fluctuate so much?
Okay, so the value fluctuation is because it is purely supply and demand, and there's a lot of speculation about the price right now. So because a lot of people are just sort of guessing if it's going to go up or down, there's nothing that really backs cryptocurrency. It's the miners that validate it. It's the hashing power towards the network. But it's not like gold or anything backs the cryptocurrency. Just like there's nothing that backs your current US dollar or any other sort of currency out there right now.
Yeah, the federal government.
Backs the dollar, and the perception that Bitcoin will progress in the future is going to push this. If there wasn't the perception, nobody would care. It all kind of goes away.
But what backs the word of federal government? Because we don't have the gold and minerals to support.
GBP, the economy.
Yeah, exactly. So the fact that people are using the dollar, the fact that is the thing that is giving it, is making it less.
We're not backed by gold anymore.
It's all fake, exactly. If you think back to the financial crisis, I mean, people lost faith in the dollar. They've lost faith in the way that people were distributing that dollar and using it. So basically, when you have hyperinflation, people value your dollars way less. And the reason that there's hyperinflation is because there's nothing that actually backs your money. Before we had a gold standard, that's done away with for almost 100 years now.
Nixon.
Nixon? Okay, well, it's done away for many years now. But basically, there's no tangible asset that backs any sort of currency right now. So because it's so widely used, because the US dollar and all these fiat currencies are widely used, they have a sort of relatively stable value along with the economy. But there's nothing to say that if everybody just stopped accepting US dollars, the price would be zero. There's no tangible reason for somebody to put their faith in a dollar, I guess.
Can you explain like transaction fees and like why you need to put a transaction fee when you're sending money? And like, so you mentioned that you know, when you get a block, like you just throw as much transactions as you can into that. But I know with the whole like SegWit thing, like we were getting block size limits, so transactions were not being confirmed fast enough. So like, my question is, how were transactions prioritized to being actually confirmed?
Right. So basically, blocks have only a limited amount of space in them. You can only fit so many transactions in a block, right? Now, when there's enough people using a cryptocurrency and they're issuing out more transactions than can fit in a block in a certain time frame that blocks are being confirmed, then you need a way to prioritize who gets included in that block. So the way that you do that is you incentivize the miners to choose your unconfirmed transaction with an extra fee that you provide for the miner, so that they'll pick your transaction, put it in the block so that it'll be included and verified and put in the blockchain.
So back in from like 13 to 16 or 17 now, like the prices went up, you know, 1,000%. What caused those jumps? Is it just more people using it? That's it?
More people using it, so there's more of a demand for it. And because the supply is capped at 21 million, there's only ever going to be a certain amount. So it's purely supply and demand. That is all. That's the only reason any sort of cryptocurrency is valued the way it is.
So I don't know if you can answer this one or not, but like, what caused that demand? Is it just people talking to other people about Bitcoin?
It was bad in certain countries.
Yeah, it's the network
People
effect.
putting their faith in basically not trusting centralized parties and really trusting people. Well, the biggest thing is people are using it. People, there's more demand for it. But the reason that people like to put their faith in it or start using it is because
It's not regulated by government, right?
no, it's all based on the people that are involved in the network, the miners that are involved in the network, and all the participants in the network.
I think I might have an input on the question you had to ask this, but to ask all of them. Sorry for asking so many questions.
No,
I know you wanted to do like one wallet, and you know, I just had so many questions. This is my last one. Basically,
It's fine, please.
You know, we were talking about what backs this, what gives value to this currency, what makes it boost. Well, you know, just from watching the cryptocurrency market, I think that's one thing that we didn't talk about. There are a ton of companies that are implementing this blockchain technology or trying to make their resources compatible with these technologies. So you'll see a lot of price rises, like you know, like you have companies like Microsoft and Alibaba and I think Amazon might have already, you know, if not, they're supposedly going to, and Google. All these people have, you know, like, as I think Chris wants to explain it to be, dedicated buildings and office spaces to working with certain blockchain technology and certain cryptocurrency technologies to make them compatible with their system. But basically, why do they do that? And also, like, yeah, sort of what is the incentive for them to do that? Why are they applying these things?
Well, the fact that we can have this distributed ledger that's secured by everybody in the network means that basically there's a huge security boost for that, because before we have centralized data storages like what Equifax had, and somebody was able to hack into that one place and get all the information out of there, right? But if we're going to try and shut down one specific node in the entire network, there are thousands and thousands of nodes. If you take one down, it doesn't mean shit, right?
Right, so it's decentralized. So it's like you're taking all of Equifax's sensitive data and you're splitting between all the clients of Equifax. It's kind of like a concept like that, or maybe even just clusters of clients.
Exactly. So
And that way it's more secure because you can only hack the individual clusters. You can't hack the entire. You can't hack this Equifax.
it's the first time that we have a sort of distributed system like this.
Right. So would you say that maybe our money isn't backed by gold or the word of the U.S. government, but it's backed by private firms and maybe tech firms and tech companies that believe in the effectiveness of the technology and maybe the transaction times and the transaction security, and in that way, this currency is backed by more than speculation.
Exactly. There's value in the network. I mean, the more people that are on the network, like, why does Facebook have any value? It's because a lot of people use Facebook. Basically, the technology behind it, this distributed technology that we can validate, and we can validate across all the entire network, and basically secure, have much greater security than a centralized location. That's a big value in and of itself, and these businesses are realizing this. They're starting to basically work and develop on these blockchains and blockchain technology, and that adds to the demand because there's more people on the network. So it raises the price.
Yeah. So you said that because it's distributed, it improves security. So that's like an availability thing because it's harder to take down every node, right? But you lose a lot in terms of confidentiality, right? Because everyone has access to it. So is anyone doing anything to make a blockchain that is still secure, that like to hide like medical data, for example? Sure, like everyone can have it, but you don't want everyone to have everyone's medical records. Is there anything in the
Exactly. So with blockchain technology, it's a necessity that there's every transaction is verified and pushed out by every single node in the network, right? But nobody knows that this transaction came from me. I don't have any sort of identification that I link with any personal identification, like my name or anything, to my wallet or any sort of particular transaction. It's just that there's a public key of an address that I own, and nobody knows who that public key is. It just says that ABC. Basically, it's a pseudo-anonymous in that way. There's also different applications like Monero, for example, is one where you can use cryptographic protocols like ring signatures to basically make it so that nobody knows hardly anything about who sent the transaction, who's receiving the transaction, but at the same time, it's still able to be validated with the beauty of modern day cryptography.
So you mentioned that with Bitcoin, there's a limit on the number of Bitcoin, right?
Yes.
So what happens to the miners after that limit is hit? How do they get paid?
Right. So before I answered his question about transaction fees, and that's how a majority of people believe that the network will be sustained, because it's there's this 21 million limit. Basically, every roughly 4 years, the reward gets halved for the miners that validate blocks. So what this means is we're not going to reach that limit until 2140.
So the value goes up, so they don't. It's not like the reward actually gets halved.
But still, after 2140, when we hit that cap, then you're just going to be rewarded. The miners will be rewarded a fraction of the transactions.
That's why a lot of the newer currencies are generating new coins, right? Whereas Bitcoin isn't.
Well, Bitcoin is. I mean, the miners get freshly minted Bitcoin.
Okay, but I mean, not past the cap. It's not as if it's a dynamic amount. It's a fixed amount that will eventually be reached. It's not like the coin will always go, like how inflation works.
Correct.
Yeah. It's a hard limit written into the code of Bitcoin.
I had a question about the hashing function of any cryptocurrency. First of all, when we get that random value, is the number of bits a constant always? Is it preset for every hashing function in any cryptocurrency?
Yeah, so whenever you put something in a hashing function, like it doesn't matter the size of whatever I put in a hashing function. I could put a whole entire book in a hashing function. I could put one letter. It's going to spit out a same fixed size.
Okay.
And is that what you were getting at?
Yes,
or?
yes.
Okay.
So that size is like they follow a standard. Is that a variable size or?
No, it's a fixed size. So there are different sort of hashing algorithms out there. There's SHA-256, where you have the output is 256.
Right.
There's SHA-1, which I believe was 128. 128. Yeah. So that would only be 128 bits.
Thank you.
All right. So,
just one more question. So, like, I'm aware that every cryptocurrency like uses a different way to decom the cryptocurrency. So, I'll ask this question: does every cryptocurrency have the same sets like bit for their hashing function, or is that just completely unique to Bitcoin?
So what mining is it's a way for people to come to consensus about what the current state of the network is. So there's nothing to say that people have to start hashing this mining procedure of creating hashes is basically just one way to get to that consensus. Okay. There are other protocols out there to sort of basically come to consensus about the network. One of such is like called proof of stake, for example, where I'm putting my own finances behind what I think is valid, and basically the block that has the most currency behind it is the one that's accepted. So it's just a way that people can come to consensus about the network.
So the hashing is just how Bitcoin comes to consensus.
Exactly. There are thousands of cryptocurrencies out there, hundreds of different ways that you can get consensus. All right. Last two questions.
Last question. Okay. What if a wallet is just a file? What, and I think there's a law. It's called, I think it's called the Clinton law, that says that you cannot come into the country with more than $10,000 of cash. What's to stop me from putting $100,000 of Bitcoin onto a flash drive and walking into the country? Like,
absolutely nothing.
Nothing.
Absolutely nothing. This technology is totally borderless. It's as borderless as the internet, even more so, because China can sort of regulate their internet access and stuff like that. But
right, and there would be no way of ever being able to do that. There's absolutely nothing you could do.
It's disrupting finance today. Finance as we know it, a Pandora's box has been opened, and I don't see how we can't just adapt to this technology. All right, last question, and then we'll get into the exercises.
So if miners are basically confirming the state of the system, what's this stop a coalition of miners from making fraudulent blocks?
Right. So because it's all distributed, it's going to be really hard to get a lot of people behind.
Well, it's not computer; it's compute power. So
it's compute power.
Amazon, Google, Microsoft will get together, and that's a lot of compute power.
Even that much is not enough to stop the Bitcoin network as we know it right now. Okay. But in this hypothetical that there is enough power to get behind it, whoever has over 50% is going to decide the fate of the network.
There is no law in the U.S. that bans carrying coming into this country with more than $10,000.
I'm pretty sure there is.
There isn't.
I think it's like
there is not.
There is actually.
No, there isn't. It's on a fact checker. It's not. There does not exist.
When you
carry $100,000,
as long as you report it on a customs.
Okay, that's true. And also, but also deposit. You also have to report it when you deposit it to a bank as well.
Yes, you have to report it, but there's no prohibition on doing it.
But if you don't declare,
one thing, there's these things called brain wallets, which are kind of insecure, but essentially you can generate a wallet from a password, and that includes the private key. So you don't even need a flashlight. All you need to know is some phrase in your head and to regenerate it the exact same way, and then you go to access your coins.
Yep.
There's a problem with gray wallets, so.
It's very insecure.
Yeah. You're taking the key space of like this to like.
Exactly. Yeah. It's that exact thing that if you put in the same, I'm going to put in the same password, I'm going to have access to those coins. So, and we can actually go and see right now how your wallet's created and everything like that. So hopefully everybody downloaded the software.
Yes. If you haven't downloaded the simulated wallet, it's like
it's a wallet. It's a Litecoin wallet.
But it's not real currency.
It's not real. We're going to be running it on the testnet.
It's like a test Litecoin currency. Litecoin's a real coin. This is like a test version of it. But you're going to simulate Litecoin transactions on the wallet. So go ahead and download the software if you haven't already. It's available in the lectures for Linux and Mac.
You have to sign in through the portal.
Yeah, so sign in through the portal. Sign into the meeting if you haven't signed into the meeting yet. If you came late or whatever, like please signing into the meeting is signing into the web app.
Yeah.
I'm gonna have you check and see how many people signed in after I said that so that I can see if I should mention it more.
All right.
Yes. Signing into the meeting is not signing into the web app.
All right. So
there's a big tile. The first tile says sign in. Once you sign in, and that'll sign you in.
okay. So once you downloaded the Electrum file from the UF
I'll tell you a message about that.
Why is it incomplete?
Once you download the Electrum file from UF sign in.
I'll put the Mac one up right now.
I want to go through what hashing the file can do for you. So basically, the only way that you can, if we think back to digital signatures, right? Basically, when people are signing messages on digital signatures, you can verify that it's come from somebody else, right? And with hashing, we can take a big file and put it in a hash function, and the thing that comes out is unique to that data, and any even bit flip in that entire data set is going to totally change the hash function. So what we can do is after you've downloaded the wallet, you don't have to trust that I didn't put some Trojan in there. We can check that the hash is actually, it spits out the same thing as the trusted software that we've downloaded. So we know that nobody actually changed what you're downloading. So the way you do that is you go to wherever you basically downloaded it to in my downloads. You can check the Mac.
It was not a full download. It was partially uploaded. I don't know why. I made that close before, but it'll be up in a second. It's only 40 megabytes.
Okay. Yeah, it's very small. You can actually just go to electrumltc.org and download it from here, this executable file. It's fine. So yeah, if you're on Mac, go ahead and go to this website and download it from here. And while you're on that website, go and click this checksums link here. And basically what this is it's a hash of the data contents that you just downloaded. So basically, the people that developed this application are trusted, and the files that they put out there are legitimate. But maybe somebody else is able to hack their centralized server and change what's being downloaded. And this can happen for any sort of software. So whenever you're downloading any software whatsoever, you should really be doing this. And a lot of the times, if you use package managers, it'll do it for you. But in some cases, it won't. So what you want to do is you can see that the hash of what they put out there is this is the hash of the file, the legitimate file. So once you download the Electrum wallet, what you can do is, I'm on Mac, but if you look at the at the specific instructions for your OS, either Mac or Linux, on the UF sign-in portal, you can see the command to put it in yourself. So what you can do is you basically take the SHA-256 hash of whatever you've downloaded. So for me, this is SHASM, or on Mac it's shasm.a, and then the download that I just downloaded, which is the Electrum wallet.
-a, not .a.
Wait, what?
You said dot, but it's dash.
Oh, sorry.
Yeah.
And you also need to specify that it's SHA-256 because there's different SHA algorithms out there as well. So you have the SHA-A256, so you're using the SHA-256 hash. And you can go to your downloads, Electrum. And we can see that this is the tar.gz, sorry. This is actually the download for Linux. I got really scared there for a second.
Yeah, yeah, I made sure that they were right for each one. Okay, I'm posting the link up just in case you don't have Slack. I'm posting the link to the wallet. Sorry we're going a little bit over time, so if you guys have to go, if you guys have class, feel free. Don't feel like you need to stay here for the exercise. You can hopefully do them at home.
You can definitely do it at home. We're going to go really quick. I'm going to just go through this really quick and show you what a wallet looks like, and sending and receiving is really quick. And there's some advanced exercises on there where you can sort of send false transactions. And you have to sort of think about how a transaction is really sent to the network. So the signing with your public key, or with your private key rather, and basically the fact that you can't send the same transaction twice and stuff like that. So they're legitimate. This is for Linux, so if I matched it up with Linux, it'd be legitimate. Anyway, because this is really new software, really new technology, the software isn't very user-friendly, but we can open the testnet version of the Electrum wallet with, and this is on the instructions as well. You can open the testnet version by specifying in the terminal.
Okay, the link is on the website. On the slide.
Okay, so if you're on Mac, it's this command right here, args testnet. And when I load up my Electrum wallet for the first time ever, it's going to see that basically that I don't have a wallet there on my machine for this for Electrum. So we can just go through the steps and basically get our wallet up and running. So what this seed is this is a representation of your private key. So this is something that you want to keep to yourself. This is testnet, so I don't care. But no way in hell I'd be showing you guys my real seed for my real Electrum wallet. So because there are a certain amount of words that are basically there's a certain amount of words in a pool for these words. So it mathematically works out so that it's going to be the same size as your private key. So any sort of combination of words is going to match up to your private key. So you want to write this down. Most people say write it down on paper, but it's testnet, so I'm just going to copy it in notes. All right, and then type it in again.
Wait, so you're not allowed to like create your own seed? Like you're sending it, but are you allowed to?
No, so the wallet software is going to generate a seed for you. And the software is totally open source. I mean, it's all on your own machine. So it's not like that these people are just giving you a seed and then they know the seed or anything like that. It gives it to you. You're creating a wallet, a testnet wallet. So you want to open it with the testnet parameter in your terminal. It should be in the instructions file that's uploaded there. So, all All right, so once I've
There's two instructions file. There's the one top level and the one in the specific Mac folder. Or,
one's the exercises that you can do on your own, and we're going to go through the first 3 here, but they're really quick. And the other ones are harder, and you have to sort of think about how signing transactions work in a Bitcoin network, how basically you can't send the same transaction twice and stuff like that. So once you've confirmed your seed, you can basically put in whatever password you want, and that's going to add another layer of encryption on your device, on your wallet file. And what you can do is you're going to want to go up here to the View tab and just view everything here. So this is basically what a wallet is going to look like. This is a kind of really trusted older wallet, so it's kind of bare bones, but I mean, it's just a graphical user interface that anybody could change the look of a wallet. So I'm going to go to the Receive tab, and this is the address that I own, and you can check that in the Addresses tab. So there are basically when you create your master seed that you just typed in, that's your master private key. And from that, we can derive a bunch of other different public and private key pairs that link, that correspond to an address. So that's what these addresses are here. So I can receive Litecoin from my address. And you want to go to testnet.litecointools.com because this is how you're going to get your free testnet Litecoin. So put in your address there. I'm going to put in my own amount of 5. It's good enough. And you'll see that it's unconfirmed initially. So what this means is there's that unconfirmed transaction in the that you've sent a transaction and no miner has put it in a block yet, right? So basically what miners are going to do is they're going to go through that mining and hashing puzzle, and they're going to end up validating your transaction in a certain amount of time. So it might take a while for it to basically get confirmed. You can see because the blocks are only supposed to come in at a certain time interval. So while that's confirming, we can basically see that we are receiving some sort of balance to this address. And this, going back to the representation of transactions and addresses, basically this means that I have a transaction. Basically, the testnet sent a transaction to me. I got that transaction output, and it's represented here in this address. So I can now spend this transaction once it's confirmed, which is going to take a while. But that's basically it for receiving. It's really easy to send and receive. You don't have to know anything about any of these cryptographic protocols to send or receive currency. So it looks like I got one transaction, one confirmation. So one block, basically with a miner validated my transaction, added it to the blockchain, and then basically there's another block that came after it. So basically, it got included in the blockchain. I have that verification that it's included in the blockchain. And then basically, once another block comes in, I'm going to get another confirmation because it's that much harder to go back and basically change what happened multiple blocks before.
Since this is just testing software, there's no one actually validating your transaction, right?
There are. People are actually contributing to the testnet. I'm pretty sure. I think that it's very low. The parameters, the difficulty for finding a block is super low on the testnet because you're right, nobody's really going to put their hashing power towards this, right? Because it's not real. It's not. They're not going to get any real value from it. But people that are interested in learning can put I can put my CPU power towards it, confirm my own transaction, for example, and basically because there's so little people that are mining on the network, the difficulty has adjusted so that I could even just do it on my own computer. Do you have a question, Elon?
I was just gonna say, yeah. So it's also practice for miners, just like it's practice for users to work on this wallet. If you are maybe interested in mining, you might go here to look at this and see how, just kind of get a better conceptual understanding of what you're doing, or something like that. Or is that not the case?
I'm almost certain that you can. I'm not 100%, so don't quote me, but I'm almost certain that you can contribute your own mining and hashing power to mine blocks on the testnet. There are certain parameters so that things get confirmed and people make sure that everything's running smoothly there. But okay, so I received, and now I can go to somebody else and just talk to your neighbor, find out their address, and basically you can send back your Litecoin around to other people. I'm just gonna send it back to the testnet because they're nice and they gave me this, so I'm gonna give some of it back.
It'd be cool if there was like a browser-only Litecoin miner for the testnet, so that when you want to test something, you just spin it up in your browser and just start mining stuff. If it was easy enough to do that, if the difficulty was low enough, that would actually work.
Well, they have.
I don't see why they're
force your computer to mine Bitcoin.
I don't know if there is out there, but it's definitely possible for it to be out there. So yeah, you can just put in however much you want to send. It specifies a certain fee for you. The wallet application just basically detects what fee is going to get you confirmed relatively quickly. But you can go and you can set your own fees with the tools, Electrum preferences. You can edit your own fees and stuff like that. So when I go and want to send a transaction, I can just press send, or I could actually preview it before. And here you can see exactly what these inputs and outputs are. So because I received 5 from the testnet, I got a transaction output of 5. So I have 1 transaction worth 5 Litecoin. Now I want to send somebody 1 Litecoin. So I put my transaction in. Basically, when I'm going to send this to somebody else, I get the public key of my address that I'm sending it from. When I sign right here, I'm basically saying that I'm valid. This is a legitimate transaction that's coming from me, and it can only come from me because I am the only one with the private key to this address. So I can sign it, and so it's valid, and you have to type in your password. And then you can basically, you've signed this, it's valid, but you haven't pushed it out to the network. So then you can press broadcast to send it out to all the nodes that are in the network. And that's pretty much it for the exercises that you need now. It's really, as you can see, it's really easy to go and just use a wallet, but there are some exercises on there that you can basically you can try and fraudulently create transactions and see what happens and how they basically validate that your transaction is legitimate.
So you had asked if you can make, what's your name? Grant. So you had asked if you can make transactions on the web browser. In one of our workshops, we set up a decentralized application, and we can communicate within the browser some fake metacoin. So
okay.
Yeah, just an example.
Okay,
cool. It's possible.
Right. Okay. So the place that this is, if you want to go in and see where the code's actually stored on your computer, it's going to be in your home directory. It's a hidden file, Electrum, or a hidden directory, Electrum Litecoin. Well, I have to do something with it. And here you can see just all the different files that go into your wallet. And that might be useful for the exercises if you want to try out the more advanced exercises. But that's all for today. Thank you for listening to me. I hope it was useful for you guys. Thank you.
Awesome, Nathan.